All right, so let's try to summarize some of the things that we saw in this entire section. So first of all, we talked about this idea of a scope, which is essentially a code block. So it's a block with a specific lifetime, and within that block, once you call container.begin lifetime scope, you get an iDisposable. And until you dispose it, that's your scope essentially. And within that scope, you have disposable components. So the scope itself is disposable, and any element, any component you resolve within that scope, which is disposable, also gets disposed when you actually dispose the entire scope. So it's kind of convenient. And let's not forget that the container itself can be disposed as well. So we have, when you call builder.register or builder.register type, you can configure the lifetime of the component. So the default lifetime happens to be instance per dependency. This is the default option. You don't even have to type it. If you don't type it, instance per dependency is assumed. And what this means is that whenever you have a dependency on a particular component, or whenever you resolve that component, you get a brand new instance. So somebody literally calls new whatever, well, obviously with all the dependencies satisfied, you get a brand new instance of that particular class. Now, and the different option is single instance, which just makes a global singleton. So essentially, whenever you have this dependency, it's always going to be fulfilled by that same object. Now, a typical concern, a typical place where you might have single instance dependencies are something like logging. If you have a logging component, you don't really need to spawn a brand new instance of it anytime you want to log something. You might want to have a single logger inside your entire system, and you might want to just acquire it whenever it comes in. In actual fact, the singleton within the dependency injection container is probably the only socially acceptable way of creating singletons. So if you're going with the classic singleton pattern in .NET, they might not be the best way to go. The best way might be to actually use a dependency injection container, and AutoFac is happy to oblige here. Now, in addition, we have different lifetimes. We have instance per lifetime. So you get an instance created per lifetime scope. Now remember, we have these scopes, and within that scope you can ensure that you get a single instance per that scope. We also saw instance per matching lifetime scope. This is a more complicated idea, the fact that you can specify one or more tags, which are just strings, and then you get one instance per the lifetime scope that matches this particular tag. So it's a bit of a tacky situation because you end up managing strings and whatnot, but you can stick them in a separate class if you want to, like a bunch of constants or something, or in a resource, and that becomes easier. And I also mentioned two additional configurations which we haven't discussed for one reason or another. So there is instance per request, which is something that we're going to discuss when we talk about ASP.NET integration, and there is instance per owner, and unfortunately it requires knowledge of owner T and the way that the dependency injection container interacts with different kind of code constructs such as owner, lazy, and so on. And that's something that we're going to talk about later on. So we're not going to, we haven't covered it in this particular section. Okay, so what else did we see? We talked about captive dependency. So that's the idea that you have a long-lived component which happens to have a short-lived dependency and keeps that dependency alive. So for example, let's suppose you have some sort of manager component which is configured as single instance. So it's a singleton which lives, you know, forever, essentially, because it's a singleton. It only gets disposed when the container gets disposed. But if this singleton takes a dependency which is satisfied by something which is instance per request, for example, then you have a bit of a problem, because you have something, you have an instance of a component which isn't supposed to live that long. There isn't really a solution for it, and AutoFac doesn't try to fix this for you, but it's something that's worth being aware of. And let's not forget that the reverse is generally okay. So if you have a short-lived component which depends on something that's long-lived, there is no problem. Like if you have instance per request that depends on, for example, a singleton, that's okay, but the reverse can be problematic. We talked about disposal and the fact that given that the AutoFac container tracks components, it can also track their lifetime and dispose of them whenever you actually need it. And this can be in many situations. For example, when you dispose the scope, it can happen when you dispose of the container, and you can do both, by the way. You can dispose the scope and then dispose the container. So you should write the kind of dispose calls which might be called twice or even more than twice. In fact, there is this expectation that whenever you write dispose, that you actually write it so that if somebody calls dispose on a component multiple times, it should work okay. And of course, you can use externally owned to prevent dispose being called. That's basically saying to Artifact that I'm managing the disposal of this particular component, so please don't touch it. Okay. Finally, last thing, we looked at lifetime events. They basically let you manipulate the components in different stages of their life, and we saw a couple of them. So we saw on activating, and that's invoked before the component is being used. So somebody has constructed the component, but the component isn't being used yet. And what you can do, among other things, which, like a property injection, for example, is you can replace instance, which basically replaces this component with another component. And so instead of yielding your component, it starts yielding something completely different. Now, I know it sounds like, well, this is a very niche kind of thing. Why would you want to do it in the first place? But in actual fact, imagine a situation where you need to temporarily substitute one component with another and then comment it out later on. Like if you're doing some sort of testing, for example, you want to replace one inheritor of some class or interface with another, you can do it and with this additional replace instance call and then get rid of it whenever you don't need it. In addition, there is on activated. So once the type is fully constructed, once all the dependencies have been injected, you have a type and you can perform further manipulations on it if you want to. And finally, the last part is called on release. That's when the instance is no longer needed and you can once again perform additional cleanup here. But don't forget that you can also make the component disposable and then do something in the dispose method. We also saw that the component can invoke certain chunk of code at container creation. So an even more niche idea, but the idea here is that you take a component and you implement the iStartable interface. And this interface has just a single method called start that you implement. And within this method, you can invoke certain commands which are done whenever the whenever the container is actually being created. But let's not forget that in order for this to work, you don't just register the component as self, you also register it as this iStartable interface. That's how Artifact knows that this component is startable. It's not going to go off looking for the iStartable interface all by itself just because you registered your component foo as foo. You have to explicitly register it as iStartable, and then everything happens automatically and the code gets invoked when the container is created.